Hello friends, I'm Bob. In this video, I will be showing you the solution to the integration of cosine inverse x over 2 dx. But before I show you the solution, if you guys like the solution, I may press the thumbs up icon below this video. For the very first step of the solution, we are going to apply the integration by parts technique. The integration by parts formula tells us that I will define a term as u and another term as dv. So this is equals to uv subtracting away the integral of v du, in which to find my v, I will integrate the dv term, and to find du, I will differentiate u term. The very first step we're going to do is we're going to express this as the integral of 1 times cosine inverse x over 2 dx, so that I have two terms, and I can now define the term u to be cosine inverse x over 2, and my dv to be the dx. To find my du term, I differentiate u with respect to x. This gives me minus 1 over the square root of 1 minus x over 2 square, and then I differentiate x over 2, I get half. This is equals to the negative of 1 over 2 times the square root of 1 minus x over 2 square. To make du the subject, I multiply both sides by dx. I get du is equals to the negative of 1 over 2 square root of 1 minus x over 2 square dx. To find v, I integrate dv, so this is equals to the integral of dx, basically is my x. I now have my u, dv, v, and du. I can apply the integration by parts formula. To move on to the next step, I get the following. My u is cosine inverse x over 2, my v is x, subtracting away the integral of v, which is x, and my du is the negative of 1 over 2 square root of 1 minus x over 2 square dx, in which the following step I would do is I would simplify the integral term. I get the following: the integral of x over 2 square root of 1 minus x over 2 square dx. And the next step I'm going to do is I'm going to further transform the integral term into looking something like this. Why? Because we're going to apply an integration technique. The differentiated function of x, fx to the power of n dx. So this gives me fx to the power of n plus 1 over n plus 1 plus c. But before I'm able to apply the integration technique, I first need to identify what is my fx, my f prime x, and my n from this integral. My fx basically is just 1 over x over 2 square. If I were to differentiate my fx, I get minus 2 times the x over 2, differentiating x over 2, I get half. And I cancel, and this gives me minus x over 2. And hence the next step from here, I express slightly differently from the previous step. I get the following. For the second term, result will be minus the integral of minus half times x, 1 minus x over 2 square to the power of negative half dx. So this is my end, and this is my fx, and I have my f prime x here. I can apply the integration technique to evaluate the integral, and I'll get the answer. So that will be x cosine x over 2 inverse minus my fx is 1 minus x over 2 square to the power of half over half plus c. And next thing is I will simplify the second term, so I get 2 times, and then I will factorize 1/4 within the square bracket, so that will be 1/4 4 minus x squared to the power of half plus c. And if I were to take the 1/4 out of the square bracket, I get half. Multiplying by 2 just gives me 1, in which this will disappear. And therefore, in the end, the final answer to this particular problem, the integral of cosine inverse x over 2 dx is x cosine inverse x over 2, subtracting away the square root of 4 minus x squared, plus c. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe for more integration problems. My name is Bob, thank you guys for your support, and I will see you in the next video. Goodbye guys.